Imagine dropping your phone, watching in horror as it hits the ground. But instead of a shattered screen, you pick it up to find it gradually repairing itself, the cracks smoothing away as if they never existed. This is not a scene from science fiction. It is a glimpse into the future of self-healing materials for durable consumer electronics. Welcome to our channel, where we delve into the cutting-edge technologies shaping our tomorrow. Don't forget to subscribe, like this video, and hit that notification bell to stay updated with the latest in futuristic tech. We value your thoughts and opinions, so be sure to share them in the comments section. Let's delve into the captivating world of self-healing materials. Self-healing materials are a revolutionary innovation designed to repair themselves after damage. The concept is inspired by biological systems, like our skin healing after a cut. These materials promise to transform the durability and longevity of consumer electronics, significantly reducing waste and enhancing user experiences. So, what exactly are self-healing materials? At their core, these materials have the intrinsic capability to repair damage without human intervention. This is achieved through various mechanisms, including chemical reactions, physical processes, or a combination of both. For instance, some polymers contain microcapsules filled with healing agents. When the material is damaged, these capsules break open and release the healing agents, which then react to fill and seal the cracks. Let's explore some compelling examples. First, consider the advancements in self-healing polymers. These materials can mend minor cuts and scratches at room temperature, making them ideal for smartphone screen. A notable example is a polymer developed by researchers at the University of California, Riverside. This polymer can self-heal even when cut in half. Imagine your phone screen repairing itself after a nasty fall. Now, let's discuss electronics that could benefit from self-healing technology. Smartphones are an obvious example. With self-healing materials, scratches and cracks could become a thing of the past, significantly extending the device's lifespan. But the potential applications extend beyond just screens. Internal components like circuit boards could also be made from self-healing material. This would mean that any micro-damage from daily use or minor accidents could be repaired automatically, ensuring the device remains functional for longer periods. Another fascinating application is in wearable electronics. Devices like smartwatches and fitness trackers are prone to wear and tear due to constant use and exposure to various environmental factors. Self-healing materials could ensure these devices remain durable and reliable even under harsh conditions. Moreover, the flexibility of some self-healing polymers makes them perfect for wearable tech, which often requires materials that can bend and stretch without compromising functionality. Let's take a deeper dive into the chemistry behind self-healing materials. The healing process can be either autonomous or non-autonomous. Autonomous healing occurs without any external intervention, relying solely on the material's intrinsic property. Non-autonomous healing, on the other hand, may require an external stimulus such as heat, light, or pressure to trigger the repair process. Consider the example of a self-healing polymer that repairs itself through a chemical reaction. When the material is damaged, the break exposes reactive chemical groups. These groups interact and form new bonds, effectively gluing the material back together. This process is akin to how our skin heals. When we get a cut, blood flows to the area, clotting and forming a scab that eventually regenerates new skin tissue. One of the most exciting developments in this field is the incorporation of dynamic covalent chemistry into self-healing materials. Dynamic covalent bonds can break and reform in response to specific stimuli, such as heat or light. This means that damaged areas can be reprogrammed to heal themselves by simply applying the right stimulus. For instance, a foam case made from such a material could be placed under a heat lamp to repair scratches and dents, returning it to its original pristine condition. Now, let's talk about the challenges and limitations of self-healing material. One of the primary hurdles is the speed of the healing process. While some materials can repair minor damage in a matter of minutes, more substantial damage might take hours or even days to heal completely. This lag can be inconvenient for users who need their devices to be functional without significant downtime. Another challenge is the durability of the self-healed area. While the material may visually appear to be repaired, the structural integrity of the healed area might not match that of the undamaged material. This could potentially lead to weaker spots that are more prone to future damage. Researchers are actively working on improving the strength and resilience of self-healed areas to ensure they are as robust as the original material. Cost is another factor to consider. Developing and manufacturing self-healing materials can be expensive, which could translate to higher prices for consumer electronics. However, as the technology matures and scales up, the costs are expected to decrease, making self-healing devices more accessible to the average consumer. Despite these challenges, the future of self-healing materials in consumer electronics is incredibly promising. Ongoing research and development are continuously pushing the boundaries of what is possible. For instance, a team of scientists at the University of Tokyo has developed a self-healing glass that can repair itself with slight pressure and moderate heat. This breakthrough could revolutionize not just smartphones, but also other electronics that utilize glass, such as tablets and laptops. In addition to improving durability, self-healing materials could also enhance the sustainability of consumer electronics. Electronic waste is a significant environmental concern, with millions of tons of discarded devices ending up in landfills each year. Self-healing materials could extend the lifespan of these devices, reducing the need for frequent replacements and thereby mitigating the environmental impact. Moreover, self-healing materials could pave the way for more innovative and versatile designs. Imagine foldable smartphones that can heal themselves from the wear and tear of constant bending, or smart clothing embedded with sensors that can repair small tears and maintain functionality. The possibilities are endless and exciting. The potential of self-healing materials is not limited to consumer electronics. These materials could also find applications in other industries such as automotive, aerospace, and construction. For instance, self-healing coatings on car bodies could repair scratches and dents, maintaining the vehicle's appearance and resale value. In aerospace, self-healing composites could enhance the safety and longevity of aircraft by automatically repairing minor damages to the fuselage or wings. The construction industry could also benefit from self-healing materials. Imagine buildings and infrastructure that can repair cracks and damages caused by natural wear and tear or even natural disasters. This could significantly enhance the durability and safety of structures, reducing maintenance costs and extending their lifespan. In conclusion, self-healing materials hold immense potential to revolutionize the world of consumer electronics and beyond. By enabling devices to repair themselves, these materials promise to enhance durability, reduce electronic waste, and open up new possibilities for innovative designs. While there are challenges to overcome, the ongoing advancements in this field are incredibly promising. As we continue to explore and develop self-healing materials, we move closer to a future where our electronics, and perhaps even our world, are more resilient and sustainable. Remember to subscribe to our channel, like this video, and hit the notification bell to stay updated with the latest in futuristic technology. We look forward to hearing your thoughts and opinions in the comments section. Thank you for joining us on this journey into the future of self-healing materials.